All right, so we're going to go ahead and finish up lesson 6.3 today. Again, the extent of what we're going to cover for this class is going to be a little limited, just because I want you guys to understand the basics of it, and it gets pretty in-depth in this lesson. So we may talk about what things do, but we most certainly won't be tested over everything it does, because it's a little bit more advanced of a topic than this class. We'll address it more in Algebra 2. So just to refresh our memory, the other day we evaluated some expressions. We identified using tables the difference between linear and exponential functions, and then we graphed the parent function for an exponential growth. We'll talk about a decay today. So this is just the filled out notes that we went over in the previous video. So I'm just going to go ahead and slide past those. Now, this is what we're going to kind of focus on in this video when b is between 0 and 1 and what that does to our graph. So again, we talked about in the previous video the parent function 2 to the x power and what that looks like. Now we're going to talk about the other side of it. In other words, the decay function. So if I take that growth function and I put the reciprocal 1 over 2, that's kind of the parent decay function. So we're going to put that table again, just like we did with the growth. We're going to start with the values from -2, -1, 0, 1, and 2. And we're going to plug those values into our function and see what that looks like. Now, keep in mind, when we did the growth function, and I just slid past it, but you should have it in your notes. The growth function at -2, we were at 1 over 4. At -1, we were at 1 over 2. At 0, we were at 1. At 1, we were at 2. And at 2, we were at 4. So let's see what happens when we plug in these values. So if I take 1/2 to the -2 power, again, we know negative exponent means reciprocal, so that means I flip my fraction, and now I can evaluate. So 2 to the second power is going to be 4. And it's going to look similar when I take it to the -1 power. Again, we just flip it to 2 over 1, and 2 to the first power is just 2. We already know anything to the 0 power is 1. And then 1/2 to the first power is just 1/2. And 1/2 to the second power, again, using our properties of exponents, we know we apply it to both. 1 squared is just 1, 2 squared is 4. So if you'll notice, the growth function and the decay function have similar values. We are just going the opposite direction. So at -2, we're up at 4. At -1, we're at 2. At 0, we're at 1. We go to 1/2, a 1/4, and it would go on and so on. Again, at -3, we would be at 8. So again, it starts big, and it comes down and gets exponentially smaller. Now, we know that it doesn't matter what power I have. If I'm taking this to any power, it's not going to change the sign of my answer. It's never going to make it negative. So the bigger that number gets, the closer it gets to 0 without actually getting there. It'll just be a really, really small fraction. Now, for this particular one, we have a negative sign out in front in this problem. So what they want us to do basically is take this new function and say, okay, I'm going to make everything negative and see what that does. So it's -4, -2, -1, -1/2, and -1/4. So if I go and look at what that does to my graph, that negative sign flips it over my x-axis. And again, it will approach 0 but never really cross it. So those two images should be mirrors of each other, and that negative sign just makes it flip. Now, for the sake of this class, I'm not going to have you guys do every single thing, But we should be able to identify what it will do eventually once we get there. But for today, I want us to really focus in on identifying the difference between a growth and decay just by looking at that B value. So for the sake of this lesson, let's just identify growth or decay, and then we can talk about what this does to it. So in this one, number 5, because it's 4 to the x power, it's going to be a growth. So we know right away that this graph is going to start like this and get bigger. Now, obviously, those are not the exact values for the table. But if I go back and I look at what this has, it's a -2. So it's going to stretch it out, and it's going to flip it over that x-axis. So when I take it times -2, all these values are going to double, and it's going to get bigger faster. So when I go to do this and talk about it in class later for the test, we're going to have an x reflection, and then we're going to say it's stretched by a factor of 2. And again, it was a growth. This one is going to be a decay. So it's going to start big and get small. And then we look at the 2 here, and we say it's going to be stretched by a factor of 2. So let me try and draw this a little bit better here for you, just so we can kind of have a better idea of what it looks like. So at -1, it's already going to be at 4, and at -2, it's at 16. It's clear up off the graph. At 0, we're going to be at 2, and then at 1, we're going to be at 1, and then a half, and so on. So it's going to look like this. The bigger that number is that you're raising to a power, so the 4, the bigger that number is that you're raising to a power, the more rapid it's going to grow or decay. So we'll look at that when we see those in the test. So like I said, we'll talk about what the stuff is going to look like, because if we look right here, this gets very, very involved. So the one thing I do want to draw your attention to is what it looks like right up here. So we've talked about functions before in vertex form. And let's just take quadratic functions, for instance. So we've talked about quadratics, or absolute values, I'm sorry, not quadratics yet. We've talked about absolute value functions and what these things do. So earlier on in the year, we said this is going to be a stretch or shrink, and it's also going to control whether we have an x reflection. We know that h is going to move it left or right, and it's going to be opposite what we think. And k moves it up and down. So if I look at this function right here, first of all, I identify whether it's a growth or decay. So we already have the parent graph for 2. The parent graph for 2 looks like this. Okay, we have those dots there that kind of represent the parent graph. Now what I'm going to do is I'm going to address these next. So +3 is going to move it right 3. So I'm going to take all those points and I'm going to move them right 3. So essentially, I want that down. So there's that. Okay, so that moves them right 3. And we did that in red. And then the +2 moves everything up 2. We'll do that in purple. So I'm going to take the red graph and I'm going to move every point up 2. And then lastly, that 4 multiplies everything by a factor of 4. So we'll do that in green. Now that's hard to see when we're doing fractions, but essentially if this was 1/4, it's just going to bump it up to 1. If this was 1/2, it's going to bump it up to 2. And then this was supposed to be at 1. That one's going to move it up 3. This one's going to move it up even more. So when we go to finally get our graph here, it's going to kind of look like this. Now, the one thing I want to draw your attention to here is something called asymptotes. Okay, so basically it's like a border. And what we have is if we shift it up to, instead of our border, like in our parent graph that we start with, instead of our border starting at 0, so here was our original parent graph. Instead of that border being at 0, because we have that +2, that border is going to be shifted up to 2. And so having this understanding of this as my boundary is kind of more important, but it's actually going to shoot up much, much faster. Pardon me. Now, as far as what we get over in this class, like I said, this is pretty advanced for what we're going to do. I'm more concerned about kind of the basics of it, so we probably won't test over stuff that has those in them. It'll probably just be things like this, those A and B values. Now, just for the sake of understanding what my graph should look like, let's talk about these really quick and then we'll call it good. Now, when we have these in our homework, like I said, I'll help you guys work these out, but let's talk about what this does. So this is stretch and X reflected. This is a growth function. So it's going to start small and get big. This is going to move it left 2 and down 1. So a rough sketch, again, my boundary is going to be right here at -1 that it will never touch. And it's going to start small and get big, but it was reflected. So it should have this rough shape right here. It's a growth function, so it's going to start small and get big. Again, 0.25 can be written as 1/4, so that's a decay. And then it just has X, so there's no left or right, but there is up 3. So again, my boundary that I have is going to be set right here. And because it's a decay, it's going to start big and get small. So that's kind of what it looks like. Like I said, the homework will have, we'll address some questions on there. We'll kind of talk about what I'm looking for quizzes and tests from this lesson. But other than that, it's just focus on those decay functions today.